Hello and welcome back to physics class. Today we are going to be looking at free fall. So free fall is the motion that occurs when an object is subject to only gravitational acceleration, meaning something is falling. Now, free fall falls under the acceleration category in physics. Remember that acceleration is our change in velocity over the change in time. And that we have a couple of acceleration formulas that we should remember, such as v is equal to v naught plus a delta t, delta x is equal to delta t times v naught plus v divided by 2, delta x is equal to v naught delta t plus a delta t squared divided by 2, and v squared is equal to v naught squared plus 2a delta x. So these are our basic acceleration formulas. Now when we talk about free fall, we don't have to add any other formulas to be able to solve these kinds of problems. What we do have to remember that our acceleration is always going to be equal to negative 9.81 meters per second squared. Negative 9.81 being the gravitational acceleration constant. Now, aside from the formulas and the fact that we have acceleration is equal to our gravitational acceleration, we have to remember a couple of things that might not be obvious in a free fall kind of problem. So the first thing is that when you throw something into the air, it eventually comes back down. And at the very moment when it starts to come back down, the velocity at the very top is equal to 0 meters per second. So that is something that you have to remember. You also have to remember that it takes the same time to go up as it does to go down, provided that we're all at the same starting point. So your delta t to go up is the same thing as the delta t to go down. Let's take a look at an example so that we can understand how to use these formulas in a free fall problem. All right, so we have a ball being thrown up in the air from the ground at a velocity of 25 meters per second. What is the maximum displacement of the ball? So like with any problem, I like to draw a picture. So I'm going to draw my ball starting on the ground, and I'm going to draw an arrow to indicate that it's being thrown up. Now I'm also going to draw the point where it's going to start to kind of come down to indicate that it goes up and then it comes down. Now my v naught is 25 meters per second. And that's all the information that's given to me in the problem. But not really, because we know that we're looking for the maximum displacement, which technically is your height here. So this is our displacement. This is what we're looking for. At the very top, when it turns direction, we know that the velocity there is 0. So my final velocity, or my v, is 0 meters per second. Now we also know, because this is a free fall problem, my acceleration is always going to be negative 9.81 meters per second squared. The only information that we don't know is our displacement and our time. So let's take a look at our formulas to figure out which formula we want to use to find our delta x. So this formula won't work because we don't have delta x. Same thing with this one here. This one, we don't have our time, so we can't really use this one. We also can't really use this one down here. So the only formula that we can really use is this last one down here. And this means that we're going to have to manipulate our formula a little bit. So v squared is equal to v naught squared plus 2a delta x. V squared is just 0. V naught squared is 25 meters per second squared plus 2 times negative 9.81 meters per second squared delta x. So the first thing that we're going to want to do is we're going to square this guy here. So 25 squared is going to give me 625. And then I'm also going to multiply these two numbers together here. So that becomes a negative, actually. Negative 19.62 delta x. I'm going to take this and bring it over to the other side. So it becomes positive 19.62 delta x is equal to 625. And to isolate for delta x, I'm going to divide both sides by 19.62 to get my final displacement as 31.9 meters. So the maximum height of the ball in this case is 31.9 meters, which, let's be honest, that's really high. That's really tall. All right, let's take a look at the same example but with a different question. How long was the ball in the air for? Now I want you to try to pause the video right here and try this out yourself. So go ahead and pause. All right, you're back. Glad to see you. Now let's go over the solution for this problem. We now have all of the variables except for our delta t. Now, since we have all of our variables, we can pretty much use any of these formulas to find our delta t. So why don't we take a look at this first one and use that to find our delta t. So v is equal to v naught plus acceleration times delta t. We know that v is 0, v naught is 25 meters per second. We know that our acceleration is negative 9.81 meters per second squared delta t. So let's just bring this guy over to the other side. It becomes positive 9.81 delta t is equal to 25. To isolate for delta t, we divide both sides by 9.81, and we will get delta t as 2.5 seconds. Now, this is not the total time that the ball was in the air for. We have to remember that this is only between the bottom of its trajectory and the top of its trajectory. So this is only half of the actual time the ball was in the air for. So now we need to take our delta t, which is 2.5 seconds, and we need to multiply it by 2 because it goes up and then it comes down. So our total time will actually be equal to 5 seconds. So total time is equal to 5 seconds. Thank you for listening, and I will see you next time when we start talking about projectile motion. Bye!